Let's do some maths for fun, and we will today typeset our solution instead of writing our solution. So we will do this with additional mathematics because it's a bit more fun than just using normal maths, and let's see how it goes out. Steady. Why does it use this? I cannot even do this. I guess I could return. This would be a little clunky, like a little weird, but still. Period of sine of 2x. Let me edit my function. Let me fix my commands real quick. I do not have answer. Okay. I'll just answer it by like so. So 2x pi 2 pi or 2. Oh my god. 2 pi or 2 is equals to pi, so the period is pi. Next we have steady amplitude of 1 plus 2 cosine of 3x. Hey yo chat, why is this so easy? Sketch the graph of oh god, I don't wanna do this. Okay, so this looks a bit weird. Hopefully you can do this. Hopefully you can salvage this a little bit. Okay. We know this is from -4 to 4. I think it is 1 centimeter. 1 centimeter. Let's take that. 4, 0 to 4 to 0 to -4 of like so, and we need to draw this again from 0 to 0, from 0 to this value. I'll take each box to be 1 by 3, so 3, 6, 9, 12, 13 is 0 and 0, 0, 0, but this is -0.1. Here on the bottom node you will have nothing. On the above node, why is this 0 over here? We will have a y, and here we have on this. Okay, we can use this to write our O. Node left. Yes, sorry, I'm bad with my directions. Left O, and this is node below x. Now we have the axes. Now we have the grid. Now for the grid, I do not really know the command very much, so forgive me for this, because I will be doing for each instead. For each x in 4 to 4, where what do? We have a draw from -0.1 x to 13 x, and for each x in 3, 6, 9, 12, we have draw -4, no, x -4 to x4, nice, and we have the labeling, which we can go on to do like so, where we have draw 0 oh god, no, negative 0.1, sorry, and this is at 2. It would be better to just use the note command. Note add 2 4 negative 2 and negative 4, negative 2 and negative 4, and we have the y thingies, the x labels, which we have node at 3 negative 0.1. No, I missed it. Yeah, this. Below at this coordinate, and what is the value of this? This is 45 degrees. 45, 90, 135 and 180 degrees at 3, 6, 9, 12. Nice, boom, we have these, and we need to draw these two functions. I do not like this. Dude, this is so big. Why is this wrong? Draw this to this left of y. Why is this wrong? No, this is wrong. Nice. Now we need to plot these two functions from 0 to 180, and I guess I will use the plot function. What do you mean, I guess? Draw plot now. This is x, and this next one will be the input. I do not know if it goes from 0 to domain 0 to 12. So let's just do sine of 2 times x, and let's hope for the best. It uses degrees. No. Rad. Oh no. Dude, what was the command? What? Huh? Okay, this y value is triggering me. Why is this y value wrong? Okay, let's first fix that. Let's just fix it ourselves. This is taking in degrees as its input, meaning that it should land. Okay, now this is 2x, its period is pi. Okay, when it reaches 180, then it should get back to 0, because at 90 we have 0, at 180 we have 0. So it should be like this, 45 is 0, that's why. We need to make this like the period like that. So right now the period is, I cannot believe we are spending this much time on it. Simple question. I'll just brute force this. Who cares? Right? I do not even know what value is this even taking. No. What is this? Okay, and let's not have this. I think it's just trying to be annoying. That's all. 32x, that should do it. No, wait, no, this is 12 long. Okay, so if this is 12 long, the period should be 12. Yes, the period should be 12. So meaning the coefficient is 360 over 12. Aha, gotcha. Nice. This is so hard to make. Now y plus 2 cosine of 3x. Okay, this should be easy. 1 plus 2 times cosine of 3 times x. But not bus, but what did you do? The period should be this. Okay, found out why this value is this. So we do 180 over our length, which is 12, which gives us 15, times our period 2, which gives us 30. So if we do this, 180 over 12 is equals to 15, times 3 is equals to 45. So 45 should be the value we should actually be taking. And it's not plotting. It's not plotting. Unknown function x and x. Oh my god. Yes. Okay, good. Why is this so bad? Serial number solutions of 2 sine of 2x minus 2 cosine of 3x. If we subtract these two, is equals to 1. For this, let's see. So this is the question, this is the part. Number solutions of this. Let's see how did you derive this. So sine of 2x minus 1 minus 2 cosine of 3x is equal to 0. We move this onto that side and is equals to this. If we subtract these two, we want to know when does it equal 0. That means we want to know when do these value equal the same y value. Okay, equal the same y value, meaning it has 1, 2, 3 intersections. 3 intersections, you can see 3 intersections. So we get 3, I believe. Yes, I do not want to talk about this. Okay, I'm getting sick from this. Let's move on, shall we? The diagram shows blah 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 tan of theta. Now I do not know if part number repeats. Okay, and I have to set it again. Okay, good. This is good. Right? I'm the best coder. Shows triangle ABC where tangent is equal to opposite over hypotenuse. Opposite over adjacent. Nice. A plus b root. Opposite 8 plus square root of 2. 8 plus 5 root 2 all over 4 plus 3 root 2. We have a as expected where appropriate, where a and b are integers. Okay, where it is appropriate, this is 100% appropriate, because this would be a long video if it was not appropriate at all. So we get the value negative 1 plus 2 square root of 2 as our answer. Okay, thank God we mathematicians are so lazy to include in quality of life features. Secant squared in the form this. And now if we differentiate tangent, no, this is not, no, we need to derive it. So we know cosine is equals to something. So let's see, P of n, cosine of theta is equals to opposite adjacent over hypotenuse hypotenuse is equals to square root of and it should yield us a value. So it is 4 plus 3 square root of 2 plus this value 8 plus 5 square root of 2 is equals to 4 plus 3 root squared plus 8 plus 5 root 2 squared is equals to a disgusting value equals a disgusting value, a even more disgusting value. Okay, this is perfect. Let's compute it normally because I want to is equals to 34 plus 24 square root of 2 plus, okay, remember this is on the inside, it's on it. What matters is what's on the inside. 8 plus 5 root 2 and it is not showing me. Okay, so let's just take the decimal value it spat out earlier of this monster, 17.178. okay, I take 3 decimal places, so is equals to opposite 17.178. it is 4 plus 3 square root of 2 it is 8.243. No, we want it in the form of this. Wait. I know. H squared. Why are we squaring this even? So h square is this value is equals to d frac, this is 4 plus 3 square root of 2, I made the same mistake again, or square root of each. No, over each. Now we want this value to be squared. Nice. Now we do the reciprocal of this. This is secant of theta is equals to the flipping of this fraction. What? Okay, nice. Sorry, I was seeing my messages. Now, we square this. So, we get secant squared of theta is equals to what? D frac h squared and this monster. Nice. I've seen that monster sound trend one time. It was like happening. And we get this squared. Nice. We can simplify this. We can simplify this like billions of times. Now this is equals h square is equal to this this above over this below. Left, right, is equals to 1 plus this entire thing squared. Now I will have a shortcut where we have this 1 plus left right square of this fraction. Okay, 8 plus 5 square root of 2, 4 plus 3 square root of 2. Nice. Look, see, we have simplified this by magnitudes, and we can now use a calculator to find that this value is precisely tangent of theta, which is equal to 1 plus 1 minus negative 1 plus 2 square root of 2 squared, right? And in a calculator, if we compute this, we get the value of 10 minus 4 square root of 2, and that is our final answer. Nice. See? This is purely shenanigans. Find first 4 times in expansion in ascending powers of x. I hate these types of questions. Okay, find the first 4 terms. First 4 terms. So it would be 2 to the 6th plus 2 to the 5th x squared plus actually 1 and 1 choose 6. 1 choose 6 plus 2 4 2 plus 3 plus 4. Let's simplify this. Okay. 1 2 3 1 2 4, and this is also 3, and if we go down here, this is 2, no, 3 4, this is 2. You know the powers must add up to 6. Nice. And these are the first 4 terms, which come out to be something is equals to 2 to the 6th. This is appropriate. 64 plus 1 choose 6. 1 choose 6 is a math error. What? No, is it 6 choose 1? Yeah. See, this is what happens when you do not do your syllabus, when you do not even revise your thingy before doing a video. 64 plus 6 choose 1 times 2 to the fifth 2 to the fifth power, which is 192x squared, plus 6 choose 2 times 2 to the fourth power is equal to 240x fourth ascending. Nice. 0 2 4 6 8. Oh my god. No. Oh my god. This last term is not even needed. Yeah. Nice. First 4 times. Find a term independent of x in the expansion of this. Now we can find these. We know that this multiply term will have up to x to the fourth power. Meaning we need only the first 3 terms of this to worry about. So let's do left 1 minus d frac 3x squared right squared is equals to 1 minus 1 times 3 over 2, 1 minus 6 d frac 6x squared plus 3 times 3 is equal to 9 x to the fourth. Nice. Correct. Now if we go along and compute everything, that'd be a little redundant, don't you think? We will multiply by the values which we actually care about. So it will be 64 times 1 plus 192 times negative 6 plus 240 times 9 is equals to a value, and this is quote appropriate 64 plus 192 times negative 6 plus 240 times 9 is equal to 1072. That is the value of the independent term. Next, give it. Ooh. Matrices are not in the syllabus. So I will award myself. I will remove 5 marks from the total. The curve intersects a line at the points. Find the coordinate equation of the perpendicular line. Oh my god, I hate this. Once you actually give the paper, you're gonna hate every other form of practice then. I need to solve this. We can do y 1 minus x is equals to x squared minus 4, and if we replace y with that, we get 3x minus 1x minus 1 is equals to x squared minus 4, giving us what? 3x squared minus 3x minus x plus 1 is equals to x squared minus 4. Now if we move the x and the terms onto the left hand side, we get 2x squared minus 3 minus 4x 1 plus 4 is equal to plus 5 is equal to 0. Very bad. 3x squared minus 3x, yeah, works out. Nice. Now at points A and B, we do not want to go about which points are A and B. There's no order given that you should follow. So this is returning a imaginary value. Why is it? So this is expanding 3x minus 3x squared minus 3x minus x plus 1. Yes, so 3x squared minus 4x and 4x remains. Why is this not like so? What is wrong? Dude, intersect the line and the points A and B. Y is equal to 3x. Why is this not working? Dude, if we bring y over here instead and set it to 0 already, so this would be 0 is equal to y x minus 1 plus x squared plus 4. Okay, this is 0 is equal to 3x minus 1 x minus 1. No, this is 1 minus x. Yeah, this is 1 minus x. Oh no. Gotcha. So this is 3x minus 3x squared minus 1 plus x. 3x minus 3x squared minus 1 plus x. So this is, if we fix this, so this is negative 3x squared negative x squared. This is negative 4x squared. So 3x plus x plus 4x minus 1 minus 4, 1 plus 4 is equals to 3. Negative 1 plus 4 is equals to 3 is equals to 0. Is this? Yes, we get good values. Nice. X is equals to negative 4 plus minus the square root of 2 times 4. Squared minus 4 negative 4 3. This yields 3 2 quad and negative a half. Two values. We take a and b to be both values. Now plug in both values into this equation. Left, right, left, what? Minus 1 is equals to, so 3 times 3 over 2 minus 1, 7 over 2. And if we do negative 1 over 2, we get negative 5 over 2. Nice. And one value will be a and one value will be b. I'll take 3 over 2 b is equals to negative 0.5, negative 2.5. Nice. Now this is getting a bit long, So we will do tabular. Nice. Now we need to find the perpendicular bisector of this line. So we need to find the midpoint. M is equals to d frac a plus b over 2 is equals to. So doing this, you get 1.5 minus 0.5, you get 1 over 2 is equals to 0.1, 0.5. 3.5 minus 2.5, we got 1.5. Nice. Midpoint is equal to this. Next gradient of this line. So let's actually compile so I can see these values much clearer. So the gradient would be 3.5 minus 2.5 minus 2.5 negative 0.5 minus 1.5 is equals to, I'm expecting this to be a negative value, 3.5 minus 3.5 plus 2.5 and negative 0.5 negative 0.5 negative 1.5, you get negative. Yes, I knew it. Equation of the perpendicular bisector. M2 is equals to the frac is equals to the negative fraction of 1, M1 is equals to 1, 3. Yes. So the line would be 1, 3x minus 0.5 plus 0.5 is equals to y. And we get 1, 3x 1 over 3 times negative 0.5 plus 0.5 is equals to a third. Is equals to y. Nice. So the line is this is the line. Nice. Let's put a box around it. Now the polynomial has factors of 2x and the remainder of 5 when divided by x minus 1. Show that b is equals to 8 and find the value of a. Now this is lazy working. Before we show them our math, we need to fix this. Okay, nice. Let's move on. So show that b is equals to 8 and find the value of a. So it has the factor 2x minus 1, meaning it has the factor x minus a half. If we do cent dev of a half, we get a 0 value at the end. So let's do this. Tabular. So this is center, and we get 4 terms. Okay. Now this is a half, and we get a negative 15, b and negative 2. Nice. Second row, I will not do it for now. We get a down here. Let's just talk about it. Okay, let's talk about it first. Then we can get to business. But first, let's label some of these so we do not get lost. A and B and C and D. A and C, D, E, F, G. Nice. A would be empty. B, so it is 8 times a half, so B would be half A, and then E would be addition of them, so it would be half A minus 15. Now we need to half this again, so if we half this, it will be the value of C. This is this. If we add this with B, what do you get? We get plus B and then this value. Now we need to half this yet again. I know, exhausting. And we get B A over 8, B over 2, and 7.5 would be, wait, let's do this. 7 is 3.5 and this is 2.5, so this is 3.75. Nice. And we know this value would equal 0. First we need to add them. So we know this would be, this entire value would be equal to 0. Nice. We know this very well, that it will be equal to 0. No, is equal to 0. Now let's do let's see what we have here. And another condition, and the remainder is 5 when divided by 1. So we need to do all this yet again. Yeah. But I hope this would be a bit more easier, tabular. Let's just do it in a new line. Oh god. Okay, nice. So there is so many sections. 1 and A, B, C, D, E, F, G, H, I, J, K, L. I'm lazy. So what would A be? A will be A, obviously. The first row will be the same. The first row will be the same. The next row will be down arrow, and I will be A. IA. Now A times 1 is A, so F will be what? A. J is equal to A minus 15. A minus 15 times 1 is equals to G. G will have B added to it. A plus B. Now times this by 1. We get nothing added to it, but we do know that this is negative 17 is equal to 5. This value should equal 5. Yes, we know this. See, both are like similar lengths. Now that we know that, we can set up two equations where we know where I'm just not going to make them pretty, So this would be a plus 4b minus is equals to 5.75 times 8 is equals to 46, and a plus b is equals to 5 plus 17 is equals to 22. Nice. If we subtract these two, we get a value and we are not escaping this one. Why am I not escaping this? Please tell me. I want to get out of here. It stinks. So if we subtract this, we get some values. This first thingy would be C, second would be C, yeah, second would be C, third would be a C, and fourth would be a C. But this could be a right, and it would be a bit more beautiful. Okay, so it would be and this would be minus and nice. If we recompile, we get this monster, which we have to calm down. Yes, just space it. It's okay. So we get the values 4 minus 3b is equal to 46 minus 22, 24, which implies what? That b is equals to 6. No, b is equals to 8. Do not cancel. Nice. So we get this value. We can just put this onto the side here to not take up as much space unnecessarily. Quad. This is quad. Yes, quad. I love saying it. Nice. Now that we have b is equals to 8, we have proven b is equals to 8, and finally what do? We prove that a is equals to something. A plus 8 is equals to 22. Quad A is equals to 22 minus 8 is equals to 14. Nice. Boom. See, very easy. Nice. Next, we can say that this would be aligned at the top, and we can also say this would be aligned at the top, and we can also say this will be aligned at the top, and we cannot say that this is aligned to the top. And Pn, using the values of a and b from part I, express f of x the form where gx is a quadratic factor to be found. You know that speed means? That's what I want to do. Like, bro, give me a break. But thankfully we just need to copy this and compute. A is what? A is, as you said, 14. A is equals to 14 and b is equals to 8. Nice. Down arrow. Let's expand this so that you can see what we are talking about. So this first term is 8. Its next term will be a over 2. What is 8 over 2? Oh my god. 7. Next we get 7 minus 15. What is it? 7 minus 15 is equals to negative 8. Negative 8 over 2. What do we get? We get 4. Negative 4. Negative 8 minus 4 is equals to 4. 4, and the last term is 4.5 is equals to 2, and this factor is indeed 0. Meaning, what do we get? We get that f of x is equals to 2x minus 1, close that, and 14x squared minus 8x plus 4. Nice. This can be further simplified, but then we won't get the correct value. No, this can be further simplified. Yes. This would be 7, this would be 4, and this would be 2. Nice. Now we get it. Now we got the value. Let's skip this step, but sure. Because the second factor can be simplified and you get this value. Why? Because when we are dividing the f of x by this factor 2x minus 1, what do we actually do? We group and we take out the two value. We take out the two value. That would be f of x, a half times f of x all over x minus a half. Okay, if we redistribute the denominator, we would find 2x minus 1 again. But we are not talking about that. When we find this value, okay, we get equal half times this quadratic that we found. A half times the coefficients of this quadratic, we get the following: 7, negative 4, and 2. This is irreducible. No. Don't talk about that. Now that we found this quadratic, we can plug this back in and see that we can recover the original polynomial f of x like nothing happened. Show that this is one root. X is equals to, we use what? Coquad. I do not like using coquad as the hence. But come on, sometimes you just got. X is equals to a half. If we go factorize, let's do something. This is 4 plus minus square root of what? Square root of wait, so this is 4 squared minus 4 times 7 times 2, so this is negative 40 all over 2 times this is 14. Delta is less than 0, meaning meaning it has no real roots. Okay, yes, this is if we simplify this will be 4 plus minus 2 root 10I all over 14, which simplifies to 2 plus minus square root of 10I all over 7. But we are not talking about complex numbers right now. 7 is the point where the point is the point. We are 1 hour in? Dude, how? I just started. What do you mean? Time flies by so fast. So unfortunately, since this video is getting a bit too long, I unfortunately have to end it here. I hope you guys like my struggle and how I code basically. Okay, if you guys have if you guys want a part 2, then I will be glad to. Okay, like, subscribe and share, and goodbye.